I'm a boat builder from the Cotswolds in the UK, and I'm currently building a boat called Temptress, designed by Michelle Berrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and modern epoxy wood construction. In this video I'm going to be making the stem stock, which is this giant laminated timber that you can see in front of me here. That's going to involve a number of different processes. So first of all, we're going to do some CNC cutting to form the jig, which allows us to laminate this curved section. Then I'm going to show you how I set up my bandsaw for resawing veneers, and we're going to cut all of the veneers that make up this incredibly strong timber. And then we will do some lamination using our West System Epoxy. So let's get started on that. First thing we're going to do is cut the jig, which will form our shape. Okay, so we've got our stem mould components cut. So you can see this consists of a couple of layers, and these join together with dovetail joints just to increase the efficiency of nesting the parts on the material, so we're not too wasteful. And those are staggered between sections so that we haven't got a joint in the same place on the two layers. So these get layered up so that we can form the lamination for the stem on this part. And I'm just going to separate those slightly so that we've got a better gapping that suits our lamination width. And it just so happens that the little waste parts that come out of the middle of here, if you cut that with a 1/4 inch bit, they are just about the right height when positioned this way to space the two lamination jigs. Now we've got a really tight fitting joint on this. This would probably actually knock together dry and be perfectly usable, but I'm just going to probably pop a bit of tight bond in there, I think, just to help keep that nice and tight over the duration of the build. So I'll get this assembled and we'll look at what it looks like when it's one complete piece. Right, I would normally consider this tool a little bit of a bodger's tool, the old hot glue gun, and I always feel a little bit guilty when I get it out and use it for something. But actually in this scenario, I kind of think this is my best option. It's going to allow me to get all of these stuck down really quickly. They set fast and it's actually really strong. And I do use this a lot for anything obviously that's not going in a boat. I'm not going to use this anywhere for anything that's going to remain in Temptress, but this is just a jig. So different kind of rules and exceptions. So I'm going to get all these parts glued down with the hot glue gun, hopefully nice and quickly. Okay, so tight bond for the second side because I want enough time to be able to get the second half of this lamination jig on here. Definitely not going to get that done before the glue gun starts to set up, so we use a mixture of glues on this one. Okay, I'm just using a square to true up all the faces of this, make sure they're nice and aligned. Okay, so our finished stem is going to be around about 75mm wide, so you can see that's going to give us just a touch of overhang either side, and that I think is going to work nicely for forming our lamination. Okay, so we're ready to start resawing some laminations for our stem, and we're going to do that on the bandsaw as you saw me do in the previous video. Having the bandsaw set up properly is critical to getting good straight resawn laminations for a process like this, and reducing waste in our timber as well whilst we're doing that, because if we start to get wandering of the blade, inaccurate cuts and things like that, all we're doing is we're just wasting valuable timber, which we don't want to be doing. So I'll show you how I set up the bandsaw for resawing. So a sharp blade is absolutely essential, so that is the first thing that we want to do. This is the blade I'm using, made by Axminster here in the UK. This is called their fresh cut blade, which based on my bandsaw, this is the best thing that I find for resawing. It's got a very thin curve to the blade, which means that we're removing minimal material when we're cutting our veneers, laminations, and as coarse a tooth as possible. So I've got a 3 TPI here, which is the most coarse they will make for this blade size. I'm going to unfold that very carefully. Okay, and we'll get that installed on the bandsaw. So we've got our bearings either side of the blade, and we've got our thrust bearing up at the top here as well. Just want to get all those out of the way. And that's especially important if we're putting a new blade on that's a different size to the previous one. It's also a good opportunity to make sure that all these bearings are freely turning and that none of them are graunching or locked up. Okay, so before I get the new blade installed and tensioned, I'm just going to mention something about the wheel. So wheels can vary a little bit from one bandsaw to the next, and you might be able to just see through the tracking window here the profile of this wheel. So this is actually curved in this direction, and that's really important for when it comes to tracking our blade. We want to make sure that our blade is tracked in the center of this wheel so that we're on the high spot of that curve. If we're too far back or we're too far forward, that's going to affect the angle of our blade when it comes down to the cutting position down here. So I want to get that blade installed, bring it up to the correct tension. Then we want to check the tracking of that blade. So we'll turn this wheel just to get that blade settled where it wants to be. And what we want to aim for is to have the main body of the blade to be in the middle of this yellow band. So we're ignoring the teeth within that equation. So here we've got about 15mm of blade, and that wants to be centered. So we really want to have the same amount of yellow behind the blade there as we do to the base of the tooth there. And that's looking pretty good at the moment. Okay, so then I'm just going to run up the saw and double check that that is staying where I want it to, that blade. And then just to show you, if I track this on the handle behind, you can see that I can take that blade forward on the wheel or back on the wheel. So even amount of yellow either side of that blade is what we're looking for there. Okay, so as I mentioned, the cross-sectional profile of our wheel is round. So that's the reason that we want our blade to be tracked in the center of that to keep it nice and square. You can see that if our blade is tracked too far back, that's going to have the effect of twisting the blade in this direction, and that's going to cause our blade to wander outwards away from our fence, which is on this side. If our blade is tracked too far forwards on that wheel, that's going to have the effect of twisting the blade inwards like that, and that's going to cut towards our fence that's on this side. So if your bandsaw's wandering in one direction or the other, then that's probably an indication that your tracking isn't correct of your blade. And there are a couple of other things that can cause a bandsaw to wander, but that's probably the primary difference. So if you have a round profile to your wheel and you're too far back, the blade's going to track outwards like that. And if you're too far forwards, the blade's going to track inwards like so. Now there are a couple of different bandsaw wheel profiles. Some of them will be tapered, but mine is rounded. So that's what I need to do, is to set my blade up in the center of the wheel. That might vary a little bit depending on what type of bandsaw you've got, but this is the process that I follow anyway. So I'm happy that we've got that tracked in the center. Now we need to get all of our guide bearings set up to support that blade, and most importantly, keep it in the position that we've got it tracked in, because we don't want it moving from where it is. That's going to undo everything that we've already done. So we've got a number of adjustments here. We've got this entire carriage that carries all of our bearings that can move backwards and forwards. So there's our thrust bearing at the top there, which you can see is independently adjustable. And then we've got our two side guide bearings as well. Now we want to get those fairly far forward on that blade so we've got maximum support. So we want probably a couple of millimeters there. We don't want to be encroaching onto the teeth because we could potentially damage them, especially if the blade comes back at all under load. But we'll see where we're going to try and avoid that in a minute. So we'll start by bringing the carriage forward to the correct place so that we're going to get support from those guide bearings on the sides. Then once that's in place, we're going to bring our thrust bearing forward. Now this is perhaps one of the most important things, particularly for straight cuts that we're looking to do in this scenario. What you've got to consider is that as soon as you push a piece of timber into this blade, you're going to load this blade. So if your guide bearing isn't properly supporting that, the first thing that's going to happen is that that blade is going to push backwards like so, under load. And as it comes back under load, it's then going to be sat in a different position on our wheel, up at the top and bottom of the machine. So as soon as that comes back, it's then going to have the effect of twisting outwards because the tracking will be altered, and then we're going to start to have cuts that wander out away from our fence. So the guide bearing is really important to maintain what we've got set up here, otherwise we'll just undo everything that we've done in the tracking stage. So we want that up against the back of the blade. We don't want it pushed hard into it. You can see we can push that blade forward if we need to, but we want to come back until we're just off the blade by a fraction, and then we'll tighten that up. And we should have just a tiny little bit, just hear that, of backwards motion. The bearing should turn freely so that we're not running right up against it, but we don't want too much movement backwards on that blade. And we've got the same down underneath here. You can see we have another guide bearing there, so we'll set that one up the same. Okay, then we want to bring in our side guide bearings. You can see they're on an eccentric cam, so they just come in. We don't want to be distorting the blade like that. You see we can actually push that blade out of the way. So we want to come in. I normally come in just until I touch the blade, then just back it off a little bit. And you can see I've got that a little bit too tight there, so this should spin freely, this bearing. Okay, and once set up, our bearing should spin freely, but we shouldn't have any movement from side to side in the blade, or very minimal movement is ideal. Okay, so with all the bearings set up, we'll run up the saw. And that's what we're looking for, nice quiet operation. We don't want to see any of these bearings here spinning around and loading up when the saw is at rest. If any of those bearings are whizzing away and spinning, it probably means you've got them set too tight to the blade, which we don't really want at this stage. They should really only start to spin once the saw is actually loaded, if necessary. So there we go, that is the bandsaw, new blade installed, ready to start cutting some laminations. Now the power feed unit is also something that I use for resawing timbers. It just helps to keep a nice even pressure and feed speed on the timbers as I'm feeding them through the blade. And this is just a little bolt-on unit that fits onto the bed of the bandsaw, and it's just a little powered roller. So each of these are spring loaded, See that they spring in and then they just drive. And we can adjust the feed speed up to what's really quite fast. I always have this on minimum. We've also got a directional switch there, so we can feed backwards if necessary. Okay, so I've got the fence on, so we'll bring that in, and then I'm going to set that fence to, we're aiming for 4mm laminations, so I think I'm going to go for around about 5.5 to 6mm on the cut, and we'll see how that cleans up once we run it through the sanding machine over there. So I'll run a first one through and we'll see how we go. Okay, so if we've got things set up correctly, we should have dead straight cuts with the bandsaw, absolutely no wander on that blade whatsoever, and basically hands-free operation as well. Well, I don't recommend being entirely hands-free, but there's not a lot you have to do other than just keep an eye on things. I hope you can actually hear me over the saw noise. So there's our stock from the board. You can see we've got nice, straight, even laminations. And we've got a pretty good surface finish there as well. So that's going to mean minimal further machining work to get those nice and flat and usable. Thickness wise, 5.3, 5.5, something like that. We're aiming for 4 to 4.5 once I've got these flattened out in the sander. So that's pretty good. I'm happy with that. Got our first stack there. We'll see how that tallies up for what we're going to need in total. Okay, so there is the dry fit of the lamination. Now I've not run full thickness laminations all the way. I've decided to stop this outer layer just here. And the reason for that is the keel fits on top of this as it comes through, and most of that actually gets cut away. That will actually run off forward there. And that gets cut away, so I thought it would be a little bit wasteful to laminate that at full length all the way. I did originally think that was going to be the plan, but I noticed the large amount of waste on it when I did the model version, and also watching other people such as Bob, who's building his boat, turned out to be quite wasteful of both wood and glue. So I figured we'd stop these slightly short here and save on a bit of cost there. We're a little bit over on the trim line, so I think what I'm also going to do is just cut these off, mark them and make them slightly longer there. But at the other end we're looking pretty good. So as a dry fit assembly, I'm pretty happy with that. I'm just going to run a dowel through these laminates down at this end, because I'm going to start clamping here and then follow on round. So I think if we have a dowel through all of those, that's just going to keep me aligned and make sure that they're not slipping all over the place once we get these coated with epoxy. So I'll make those couple of changes and we'll take all this apart, and then we can start the glue up process. Okay, so I've got unthickened epoxy in my roller tray so I can wet out my laminates first. So I'm going to do that. I'm not going to leave a huge amount of time for these to tack up really, just because of the fact that that would mean I basically have to lay everything all out, and I've got risk of kind of losing the order of these laminates, which I don't really want to do because of the dowel hole that I've drilled in them, and I need a massive amount of surface area. So what I'm pretty much going to do is just roll this out with unthickened epoxy and then apply the thickened epoxy to the joint, and then we'll assemble it pretty much straight away. Okay, so for the thickened epoxy, I'm using the 404 high density filler, which is really good for high strength laminations such as this. And it gives a really nice, smooth, thickened epoxy. So we'll put that on again, notch spreader with the fine tooth in between each laminate. Okay, so there is our stack of laminates, all glued up and ready to form the shape of our stem. Now I've got this laid out in a piece of polythene here, which is big enough to encase it, so I'm going to wrap this up like a little parcel, and then we'll load it onto the jig. I like to do things that way because it's a really clean way of working, and it just means you can handle that without even the need for gloves on really. It's not going to get glue all over my clamps, it's going to keep everything nice and tidy, and it's just generally a good way to do these laminations, I've found. Okay, so there's the glue up. Plenty of clamps on the go, as you can see. The MFT table with the holes in is coming in really helpful for this. It's allowed me to actually clamp down in some cases. So you can see here I've got these bars that run across the lamination, and that's just pulling all of my laminations nice and flat and pulling them down, making sure that none of this is riding up anywhere, which should make the stem a lot more square and mean that we've got less shift between the laminations throughout. So you can see I've done that in a few places throughout, and that was really helpful to be able to do that. Plus I've also clamped down my my jig. Really happy with that. I'm pretty pleased with how this is looking. We've got a nice fitment of that all along the inside edge there of the jig, and you can see we've got a good squeeze out. You can imagine what this would be like to do had I not wrapped this in plastic. This is nice and clean, you can work around it, you've not got an epoxy anywhere. You can see by the amount of squeeze out in that just what state all of this assembly would be in if I didn't first wrap that in plastic. So that is a definite recommended way to go if you're doing something similar. So there we go, that's glued up. We will leave that to cure and we'll revisit it tomorrow. Okay, first look, looks really good actually. Obviously a little bit difficult to see the true glue line at the moment, but we need to get that cleaned up first of all, but looking pretty nice so far. That is a substantial piece of laminated timber. So we'll get that downstairs, we will run it through the sanding machine, get things cleaned up and have a proper look at what we've got there. That is a serious piece of laminated timber. You can tell just by the tone of this as well how consolidated and tough that is. Really pleased with that. Can we just take a moment to compare this to the stem when I did the quarter scale model as well? See the difference in size between the two. So spring back I'm fairly happy with. We've got probably, I think, 4 or 5 millimeters there at the tail end of this. So that's really nice.
So I'm actually going to do some things that will completely eliminate that spring back. So I'm actually going to CNC carve the stem, if you hadn't already guessed it. So we'll do that a little bit further down the line in the next video, I think. But that will mean that I'll be able to cut the back edge of that stem to correct that. And it's not a huge problem anyway, because as I talked about in the model series, there are ways that we can overcome that and lose the difference there. But I'm really pleased with how this stem looks. The glue up of that is incredible, if I do say so myself. I'm really happy with that. There's no voids anywhere in this, and that is an incredibly strong piece of timber, so I'm really looking forward to getting that carved and final shaped before it goes into the boat. Okay, so that is our stem stock. As I mentioned, I'm going to CNC carve this, so there's still a little bit of work to do to it. We're a little bit over thickness at the moment, and I think what I'm going to do is a facing operation to bring that down to final finished size when that's on the machine. This is quite a complex part, and there's a lot of work still to do to this actually. Now, if you were building the boat manually, as I've designed the plans for, this would go into your assembly now. And all of that work gets done as you install the topside battens and things. As I have the information in CAD and I have the ability to put this back on the machine, and obviously I want to try and push the boundaries a little bit, that's what I'm going to do. So I'm going to do a carving operation that's going to cut the bevels onto this. We're going to remove all the excess stock, and we're going to cut notches for all of the landings for the topside battens, the shear clamp, and all the chine components that come into this as well. So this is actually quite a complex part. When you see its finished shape, once all of that's done, there's quite a lot going on. That's going to be a bit of a head scratcher with regards to CNC work, but I'm quite looking forward to the challenge. So I'll do that in the next video. We'll get this on the machine, and we'll see what we can do to finish it up. As always, I want to say a massive thank you to the patrons and the sponsors that are supporting this project. This wouldn't be really happening without you guys, so really appreciate your additional support. And also to you guys for watching the videos, because without views, none of this works anyway. So really appreciate all of that support. Hope you've enjoyed this video, and in the next one, we'll get this on the machine and get it carved. So thanks for watching, hope you enjoyed it. Cheers guys.